start or wait for a little more while?
We'll start, sir. Almost 30 have joined.
Okay.
So, good morning, sir. And on behalf of all the participants today, I am inviting Professor Kamaiah, V. Kamaiah. He is a very senior professor in subject of economics. He has served University of Hyderabad for a fairly long period as head and dean and senior professor in School of Economics. He had been dean also for there. In 2017, he retired there, and now he is emeritus professor in University of Hyderabad. He has been associated earlier with different institutes of repute, like Institute of Social and Economic Change, Bangalore, RBI Chair Professor, Indira Gandhi Institute of Development Research, Mumbai, and National Institute of Bank Management, Mumbai. Sri Mata Vaishno Devi University, Jammu, Ahmedabad University as a visiting professor, and he is in board of directors of MDI Gurgaon. So he's having a very rich experience in the field of academics and academic administration. He has written more than 150 research papers in different national and international journals of repute. He is in the board of various Scopus and Web of Science listed journals. He is editor in reputed journals. He has guided more than 50 research scholars. So we are having a chance now to get some enlightening from his experience, rich experience. So, sir, now time is yours, sir. You can start. And we are having some nearly 37 participants. Most of them, nearly 50% of them are from commerce. And some 15 to 12 are from economics, and some 5, 6 are from management subject. Nearly half of them are PhD holders, and remaining are either pursuing or they are about to join research. And they are representing 14 states of India. So they are from different part of India. And now, sir, time is yours. Our participants are not having access to audio, so they will be putting their questions in chat box. So towards end of the session, I will post these questions. I will read these questions for you. So, sir, now you may start, sir.
Yeah. Professor Bhartendra Singh, coordinator of this refresher course in economics, commerce and management. Professor Haribabu, head of the Department of Economics, and other faculty members. I'm very much pleased to be here this morning to spend some time with all of you, to share my experience, as well as to talk about the chosen topic, that is the sampling techniques. Well, sampling techniques form an integral part of research which involves primary data collection. As teachers, all of us tell our students that the scholar should be very careful in observing or following various stages of research. That is, to identify a research problem and to raise the research questions. We also tell the student that a critical review of survey of literature is important. Then from the survey of literature, possible gaps are identified, research questions are raised, then the objectives and hypotheses would be set. Then the next and the most important thing is setting the research or study or the sample design. So that is where most of us struggle to help the student how best the research design would be formulated. Then this is followed by the data collection, data analysis, and report writing, which perhaps is the final phase of finishing a doctoral dissertation or, for that matter, any research project. So, while following the sequence of steps, we come across the research design and how to formulate the sample design. It is here that we need to spend a lot of time with the scholar. When it comes to preparation of questionnaires, preparation of schedules, based on our knowledge of the problem, based on what happened in the previous studies, we will have some idea about how to synthesize all the ideas and how to identify the requirements of data and how best we formulate the questionnaire. Then comes the issue of sampling process. So how do we go about collecting the sample? So there are certain established sampling techniques. So my today's lecture mainly focuses on the various sampling techniques that are popularly used in literature. Broadly, we can classify the sampling techniques into two categories. One, probabilistic sampling methods, and two, non-probabilistic sampling methods. It is essential that we should know very clearly the distinction between the two. In the case of the probabilistic sampling methods, what is important is the element of randomness. That is, randomness is used while selecting the sample respondents or the sample units, whatever it is. And the randomness is predetermined at some chosen level. So which means that the randomness cannot be arbitrary. It is at a predetermined level. And the important assumption is that the population is homogeneous, whether it could be in terms of strata or whether it should be purpose oriented or whatever it is, some kind of homogeneity in the population is expected to be there for the probability sampling to work more effectively or more efficiently. The second one is the non-probability sampling. So in non-probability sampling, the researcher has the choice to pick up the items or the respondents. Okay. In the process of picking up, at the back of the mind of the researcher are the non-random factors such as convenience, availability of the respondents, or access to the participants, location, and more importantly, sometimes the cost considerations of the research project. If we ask a research scholar to conduct a survey which involves, say, 1,000 and odd respondents, it becomes very difficult. It's not at all a feasible proposition. Therefore, while deciding upon the sample size, we should be very considerate with regard to the cost of the project. If it is a doctoral project, I think it should be a moderate one. If it is a funded project, depending on the quantum of funding, the sample size would as well be very large. Okay? So now, given this broad categorization of probability sampling and non-probability sampling, the idea is to collect data It could be qualitative or quantitative. It could as well be information, especially when it involves conducting opinion surveys. It could be simply gathering of information. Okay. Now, what are the main sampling techniques that are popularly used in research in social sciences, commerce, or even management sciences? Okay. So, going by the broad classification, we have 4 or 5 important sampling techniques. The first and foremost of them is the simple random sampling. Okay. So what is this simple random sampling? All of us know about it. In simple random sampling, the idea is that each and every sample item or respondent should have an equal chance of being included in the sample. I will give a few examples. Let us take the case of a very practical, mundane example, a bag of rice. If the quality of rice is to be ascertained, it's not impossible to take into account the whole grains that are there in the bag. We take a sample of a few grains and test. And based on that, the few grains that we collect, we assume that the whole bag would be of a particular level of quality. So that means the grains that we pick up should be representative of the entire content of rice in the bag. So this is one simple example. Suppose we want to say examine the impact of COVID on particular socio-economic group or groups. Then we first identify the population. Say, for example, how people in the lower income categories are affected by COVID. If that is the consideration, we carefully select the population consisting of that particular group. Here, the idea is that the group consists of homogeneous individuals. So, from that, if we sample the respondents, each of the respondents should have an equal chance of being represented in the sample. Okay. Now let us take an example from agricultural economics. Okay. So let us take the case of, say, dryland farmers. Okay. If the study is to highlight the issues that are involved in dryland agriculture, we first select a block or a district wherein dryland agriculture is widely prevalent. So from that is our universe, that is our population. So from that, we select respondents. So each of the respondents should have an equal chance of being chosen, being included in the sample. So that is how, we apply the uh, simple random sampling procedure for arriving at a sample which is supposed to have been drawn from a population which is homogeneous. And using this principle, it is expected that the sample should be a representative sample. Okay. This simple random process we can apply whether there are prominently 2 techniques. So one technique is a lottery method. Okay. So each of the respondents may be assigned a particular number or a code. All these are all put maybe in a tin. All the numbers or codes would be shaken up and randomly certain numbers are picked up. Okay. Then another method is the use of random numbers. I think some of us must be very familiar to the random numbers, how random numbers could be generated, and how the generated numbers could be used in the context of picking up a sample which has random character. Okay. So in the lottery method, again, we can have the replacement as well as non-replacement procedures. We are not going into those details, technical details. But now to summarize, the essence of the simple random sampling is that we should select a representative sample which truly represents the population such that every respondent or every item in the population has an equal chance of being represented. Okay. So the next sampling technique, which is equally popular, is the systematic sampling. The systematic sampling is used in a context where the population is large. That is, the size of the population is very large. So in systematic sampling, what we do is we first select an item. That is, an item is chosen. Okay. After that, we invoke a rule that is the sampling interval. That is, after how many items the next item would be chosen. And this sampling rule is predetermined. Suppose we want to have 10% of the population as the sample. Okay. So this 10, therefore, is the interval. Okay. So now we select any item from 1 to 10. Say, for example, item number 3. Item number 3 or respondent number 3. So next we add 10 to that. Next is the 13th of, respondent is chosen. So like that, we cover the entire sample, right? In a very systematic way. Okay. So here the assumption is that the items or the respondents are arranged in some order, in some meaningful order. If that is done, then it is expected that the sampling procedure would be efficient and straightforward. The population should exhibit a clear order to ensure uniform selection. Of course, that is the assumption, but the advantage is that it should give us an efficient and straightforward procedure for picking up a sample. But the disadvantage is that it may lead to a bias. It may lead to bias if the population has a kind of pattern which is not uniform or which is not recognized kind of pattern. That is, suppose if the pattern in the data in the population, if the arrangement is irregular, then naturally the systematic sampling procedure may not work. Okay. So what are the various, just a moment. Yeah. So in systematic sampling, we have noted the advantages as well as the disadvantages. So next is the stratified random sampling. Okay. So in stratified random sampling, here the assumption is that the population is divided into some kind of strata, some kind of groups. Okay. So that means the population under study is not uniform. For example, the states in India. Okay. the district in a particular state, or the firms in a particular industry. Okay. So in terms of size, they vary. Okay. So like that, we can pick up, a number of examples. So if we need to have a macro view of the economy or the Indian picture, if we want to have an aggregate picture in a context of this kind, then we need to have a look at dividing the entire population into certain strata. Okay, so what kind of strata they could be? Can the strata be arbitrarily divided? Can it be an arbitrary division? No. They could be natural formations. For example, regions. Regions are naturally formed. We cannot do anything about the regions. And we have to accept the regions or the groups, which we may call it as strata, or given. Given that, okay, so from each strata, how to pick up a sample. So here, the stratas could be identified first. Then from each strata, either we apply the simple random principle, or we can also have the systematic sampling techniques. So to arrive at the desired sample. Okay. So in stratified sampling, first we should be very clear about the object, should be very clear about the target. So what the researcher wants should be very clear. Then accordingly, the strata should be chosen. Then the groups which are predefined, okay, should be well-established groups. We should be able to recognize these groups, okay. Then random sampling could be resorted to. So the advantage is that all identified groups are represented. That is the advantage of the stratified sampling. But the disadvantage is that it requires, that is, this procedure requires knowledge of the population. Okay. Of course, not only for this technique, even for any other, knowledge of the population is very essential. But in this case, it is much more so. Unless we have knowledge about the topography, the living conditions, the soil, the economy of each of the strata, we won't be able to meaningfully perceive the existence of various groups. Therefore, we should have sufficient knowledge of the population. Okay. So the next important technique is the clustering sample. Okay. We all know the meaning of clusters. Okay. So clusters are groups, not individuals. Okay. So they are chosen at random. Okay. So they are naturally formed groups, clusters. Okay. So clusters may be pre-existing, or the clusters may be identified. For example, if we want to know the study habits of a particular batch of students, so here the cluster is the batch. Okay. And if we want to study the behavioral patterns, the social behavior patterns, such as, for instance, smoking, okay, of a particular group of students, they form a cluster. For example, the teenagers, boys, they form a cluster, right? And if we want to have this clusterization based on, say, for instance, gender, okay, that could be a cluster, right? So in cluster sampling, first, we have to identify the groups, or we have to identify the clusters. Having identified, then how to draw a sample? That could be done with the help of a two-stage cluster sampling, two-stage procedure. In the first stage, randomly select the clusters. So that means, suppose now in a particular state, we have students admitted in the first year of a particular course. Okay. So there are so many colleges, and hence there are so many clusters of students from each of the colleges. Okay. So first we identify rather randomly the clusters. Say, for example, from which college the first year batch students are chosen. Like that, the batches or the clusters are chosen at random in the first place. Then in the second phase, okay, within each cluster, we select the sample, that is the respondents, in this particular case students, rather randomly. And while choosing the random procedures, we may adopt to the simple random sampling technique or even systematic sampling technique. Systematic sampling technique if the population is the size of the population is large, where a simple random uh, technique may be used if it is relatively smaller, right? So then, what are the advantages? The first and foremost advantage is that it is economical. It is economical and logistically it is somewhat easier to conduct the survey. Uh, the idea of picking up from each of the clusters is that the sample gets uniformly distributed and we are able to complete the survey or whatever job within a reasonable budget and also reasonable time span. The disadvantage is that there is a possibility for greater sampling errors. This is due to the potential similarities within the cluster. For example, within each of the clusters, there are certain similarities. So that means the sample consists of those respondents who may give the same kind of information, So this is the disadvantage if we strictly follow the cluster sampling procedure. Okay. So these are, the major sampling procedures. That is the simple random sampling, the systematic sampling, then stratified sampling, and the cluster sampling. So one may get some doubt here. What is the difference between the stratified sampling and cluster sampling? Okay. In the case of stratified sampling, okay, so we perceive the groups and we make the groups. Whereas in the case of cluster sampling, groups are already there, existing groups. Perhaps they are naturally formed groups. We are not venturing to do any grouping. Whereas in the case of, dividing the population into certain stratas, right? So there is a possibility for discretion. And of course, there is also a possibility for some kind of bias, subjective bias on the part of the researcher. Okay. So in all, what do we conclude from this? Okay. Suppose now we resort to one or the other of the sampling procedures based on the principle of randomness. Okay. What does it ensure? The critical questions that we may ask is that, okay, what do we ensure that? Okay. Is it that we are going to minimize what is known as the sampling error? Is it that we are going to minimize what is known as the sampling bias? Okay. So these are some of the questions which we may like to answer. Second issue here is that how large should be the population? Okay. Suppose if the population is very large, then it becomes infinite. If the population is small, it could be finite, right? So the process of drawing or fixing sample size, when the population size is infinite, is slightly different from the population size when it is finite. These are all some of the technical details. But the general idea is that as we increase the population size, the sampling error tends to be minimum. Okay, this has been a well-established proposition, and it is quite intuitive and it's quite appealing. Now, when we advise the student to go for a particular sampling procedure, okay, what are the problems that we encounter? Practically, what are the problems that we encounter? Okay, so there are quite a few problems at the ground level that we encounter. The first one is our knowledge about the population. Okay, what do we know about the population? Right, we are as ignorant, to put it in very simple terms, as the scholar himself. But we have certain notions. For example, take the case of dryland agriculture. We tend to feel that farmers behave in a particular way. We tend to feel that they have difficulties of this sort of things. Okay. But then within the dry farming, we have a variety of farmers. And each of the farmers has a different kind of experience, different kind of perception about how to go about doing the cultivation. Okay. What are their expectations about the climate change? What are their expectations about the quality of seeds, etc.? So therefore, it is important to understand about the nature of the population from which the sample is to be drawn. First, we need to understand that. Then accordingly, we have to suggest a procedure. Which of the sampling procedures that we just listed above would be more appropriate to the context? That is, simple random sampling, cluster, then stratified, etc. Which of them is more appropriate? That could be decided. The second question is, what should be the sample size? Okay, what should be the sample size? Is there any rule of thumb? Is there any formula for arriving at the size of the sample? In fact, this has been the crux of the matter. So while deciding on the sample size, okay, we tend to economize on that for various practical considerations. But statistically, there are some computing procedures for arriving at the sample size for a given population size. Okay. Now, if we compromise on the sample size, on economic considerations, what are the difficulties involved in that? Okay. Would the quality of the data suffer because the sample is restricted? Would the quality of the data suffer because the sample is not adequately represented by the population? So these are some of the considerations. So in this, it is necessary to recognize that the size of the sample influences two important statistical properties. They are precision of our estimates. That means the data that we collect ultimately would be analyzed using some statistical tools. They may give us estimates either through parametric methods or non-parametric methods. The size of the sample influences, or it will have a bearing on the precision of the estimates. Then second, also the power to generalize the finding, because most of the primary data studies, okay, confined to one point of time and confined to a few locations, we try to generalize it in a wider space. Okay. So for this generality, there are obvious limitations. Obvious limitations. Now, the limitation which is inbuilt into the data of this kind of nature would be magnified if the sample size chosen is not appropriate. Then the question is, what should be the appropriate size? Should we go mechanically on the basis of the sample size calculator, or should we use our discretion to do that? If discretion is used, then subjectivity enters. If the mechanistic formula is chosen, then they tend to be very mechanistic and it will have some difficulty or the other. Then what is the appropriate sampling procedures that are followed? Now, to be very honest, all of us as teachers who have been guiding students, what is our take on this? Is it that we are following scientifically, ceremoniously, the uh, sample fixing procedures, statistical procedures, or we are using some kind of judgment, right? Or we are mixing both to have some idea about the size of the sample. If we say for a doctoral dissertation, 400 should be enough or 500 should be enough, but not more than 600. These are some of the ideas that dominate our mind. But then this 400, 500, or 600 would tend to be an arbitrary number if we don't take cognizance of the size of the population. Then what is the size of the population? If we enhance the space, if we increase the volume of the population, then any sample that may be drawn that is fixed out of these procedures would tend to be inadequate. So therefore, there is a need to follow statistical procedures, and at the same time, we also need to have a comprehensive understanding of the nature of the population and confine its boundaries, then synchronize it with the desired sample that we may like to have for operational reasons. Okay. So now there are certain steps which need to be kept in mind while fixing the sample size. One is the population size, that is very and that is very obvious. Second one is the margin of error. What is the margin of error? That is the confidence interval. Suppose now, imagine the population may have a mean and the sample also may have a mean, which we calculate from the data. Okay. So the population mean is expected to lie within the confidence interval. And how is the confidence interval computed? We take the mean plus or minus some sigma limits. Okay. So within that range, which we call the margin of error, the population mean is expected to lie. Okay. If this happens, then what is the level of confidence? Is it that we are able to do it with 90% level of confidence, or 95% confidence level, or 99% confidence level. So the level of confidence also assumes significance while calculating the size of the sample. So then the variance that we are talking about, okay? See, how do we get population mean? Because we do not know. We have not, conducted the census survey of the population. So how do we estimate the population mean? So population mean, here the assumption is that the sample mean is an unbiased estimator of the population mean. So by making use of this assumption, okay, and making some adjustments, we estimate the population mean and see how the population mean would be closer to the sample mean within certain bounds. Then finally, we arrive at the sample size. So for arriving at sample size, as I just mentioned, there are two ways. One is for finite sample and other is infinite sample. Okay. So I'm not giving those technical details and all that. But here the broad idea is that sufficient care has to be taken while deciding upon the sample size in two situations. One, in the context where the population has, a very large population, that is, size is infinite, and second is finite. So for finite samples, you have a slightly modified formula compared to an infinite sample. Okay. In the beginning, we were talking about the other stream of sampling procedures, that is non-probability sampling procedures. So what are they, and what are those procedures, and how important they are in the day-to-day research in the emerging areas that we are interested in, that is currently economics, commerce, and management sciences. Okay. The first one that we may like to talk about is the convenience sampling. As I mentioned earlier, in non-probability sampling methods, okay, we are not really worried about the randomness. Okay. It is out of convenience. It is out of, for a given situation, it is out of some kind of accessibility, etc. Okay. Now talking about the convenience sampling, here the items are chosen or selected on the basis of availability or accessibility. Accessibility. Here the example is, in convenience sampling, it is convenient and straightforward. What you want, you just pick up. Okay. But the disadvantage is that there is a possibility for subjective bias. That is, it is susceptible to bias. Okay. How do we select a convenience sample? Can we think of some examples? Okay. First is the case of marketing studies. Okay. So in marketing studies, we do have the feedbacks from the buyers. Okay. What do they feel about the product, etc. But buyers are heterogeneous lot. Okay. But now, how do we really go about doing the survey, which involve whose objective is primarily to know how the given product is doing well or not? Okay. Suppose now, if a good report is to be generated, we pick up conveniently those people who would tell good about it. For example, people with high purchasing power, if we contact them, then they may not crib about the pricing. They may say, yes, it's very good, it is correctly priced, and maybe quality of the product is also good, etc. So conveniently, if we pick up sample, because they are available, because they are forthcoming, but if they happen to be from a particular, group, let us say uh, higher or upper income groups, then we tend to incur a kind of bias. But by doing so, we can quickly complete the survey and go ahead with that. So the idea is that in convenience sample, the advantage is that it's straightforward. The advantage is that the researcher has the flexibility to pick up, and the flexibility is guided by the principle of convenience. Okay. The next is quota sampling, right? So in quota sampling, the aim is to achieve spread across the targeted population by specifying who should be chosen for survey according to certain groups or criteria. For example, if our interest is to know how the gender is performing in a particular context, how certain ethnic groups reveal their preferences, how people of a particular income strata, how do they decide about their buying or buying decisions. Then how people of certain age brackets, for example, senior citizens, teenagers, etc. So in quota sampling, what is essential is that we pick up from each of these groups to have a holistic picture about the population. So in quota sampling, from each of these groups, we fix a quota. Say from women, this many should be there. Mhm. Then from aged people, senior citizens, this much of should be there. People of particular income strata, so many people should be there. People of, say, living in far off hilly areas, again, certain number of people. So like that, in quota sampling, we cover the entire area or entire, population. And that is possible only when you fix some quota. And within that quota, okay, within that quota, then uh, you can have the sample, okay, based on discretion. So there, you are not guided by any random principles. You can use your discretion. And how the discretion is now implemented based on convenience. Whoever is available, you approach them and then pick up. Okay. So in quota sampling has very many applications, especially when welfare programs are to be implemented. Okay. So then this quota sampling is highly useful. Okay. Because welfare has to reach various sections of the society. So the vulnerable, the target group should be represented adequately. Accordingly, quota has to be fixed. And similarly in jobs, in reservation of jobs, quota system has to be implemented to ensure social justice, right? So that way, quota sampling is highly useful. But here, the arbitrariness is that there are no ground rules as to how many should be selected from each of the categories. What should be the quantum of quota? It's not, given anywhere. For example, if there are a few posts, say, reserved for a particular community, we really do not know how many people are eligible, qualified in that group. Okay, whether the number of posts to be filled should be representative of the all the people that are there who are qualified, etc. So that knowledge is imperfect. Imperfect. But here the idea is not that. Here the idea is that you basically, take people from that category, you fill from that quota. That is uppermost in the mind, not really knowing much about the population. It is enough if the groups are clearly defined. Then within that, you have the discretion to fix the sample size based on, say, as I just mentioned, based on convenience, based on some subjective considerations, or subject to certain characteristics, well laid down characteristics. For example, if a post is to be filled by physically challenged people, here the guiding factor is that the eligible person should be physically handicapped. So therefore, people should be picked up only from that category. This is how the quota sampling works. So next, non-probability sampling technique is the purposive sampling. This is also known as the judgment sampling. In the case of judgment sampling, okay, so this is based on goals at hand and knowledge of the elements respondents to be chosen. Actually, in purposive sampling, the respondents or the items are fixed with a particular purpose in mind. Okay. So while doing so, it may not represent the population. So that means from purposive sampling, the sample that we draw may not be representative of the population. This is one constraint. However, what is the advantage of that? So you want, whatever you want, you may be able to pick because you have a definite purpose. You have a definite purpose. Okay. So accordingly, you pick up the sample. Okay. But then why do you do that? What purpose does it serve when you resort to purposive sampling? Okay. It is ideal, rather, it is very useful for studies that require special participants under some specific conditions. That is, you lay down a specific criteria or characteristics that need to be specified a priori, beforehand. Okay. So your purpose is guided by the characteristics. Like in the case of quota sampling, there is overlappingness between the two. Okay. Here the disadvantage is that the highly subjective based on the judgment of the researcher. I will give an example. Suppose you want to identify the impact of drugs on society. Okay. So here the question is, who are the drug peddlers and who are the consumers or who are the victims? So for that, how do you go about doing this? Okay. So you identify the groups. You identify the groups. You have a purpose to see how the whole mechanism of trafficking works. Accordingly, you choose, depending on the purpose, the people. But these are very specific groups. They may not be forthcoming in revealing the information. They are all very specific, uh, sometimes very secretive groups. Okay. So in such cases, the purpose is the overriding factor guiding the sample selection. So the next important thing is the snowball or reference sampling. The snowball Sampling is very popular in certain areas of management science and also social and behavioral sciences. What is the essence of this snowball? Okay. Since snowball, there is no other rhyme or reason behind that except this is based on picking up the sample by identifying a referral point. So that is, you identify an individual, he refers people, he refers people whom he knows, he or she knows. Then those people in turn, they refer others whom they know. So like that, it goes on. Okay. So that means the participation in the survey, it radiates through a community of connected individuals, connected individuals. Like, the snowball rolling down the hill. Okay. So this is another technique. Because normally in certain secret groups, you won't be able to get information. Obviously, if you go with a schedule and all, nobody will give you the information. So I identify a link who in turn will refer you to some people. They in turn will refer to some other people. Okay? So in snowballing, the advantages are you get over the hard to find research or hard to tackle the secretive population groups. So for certain important studies, for example, suppose you want to identify the insider trading. It's a secret group, insider trading. So how do you do that? With some difficulty, you identify one person who resorts to the trading. So from him, using all your skills, you extract information about who are the other people, etc. So only through referral, because it's a very secret group, will not come out in the open. Okay? So this snowballing sampling technique may help. Okay. So in summary, in summary, the non-sampling research techniques are very useful in certain contexts. They do not follow any logic of randomness. Some element of subjective bias, some element of arbitrariness would creep into these studies. But they become inevitable because in certain contexts, it is highly essential that you need to resort to non-probability sampling techniques. Okay? So for a research survey, one should be very judicious in picking up the kind of sampling techniques, whether flowing from the probability stream or non-probability stream. Sometimes a judicious combination of these two, though they may be incongruous, sometimes they may be profitable. Okay? It all depends on the context. It all depends on the situations. So that is all I would like to share as far as the sampling techniques are concerned. I have given a bird's eye view of the two broad categories of the sampling techniques and the procedures. We have also noted their constraints. Okay. So now I may like to invite some questions, if any.
Sir, we have received 3 questions so far.
Yeah.
So I'll just pose this question. First is from Dr. Daneshwar. He's asking if in my study, the population are the customers of LIC.
Okay.
So which sampling technique is suitable for selecting the sample for this population size?
Okay. So your customers are
LIC customer.
yeah, yes, they have taken policies, LIC policies.
Yes.
So that is your population.
Yes, sir.
That yeah, that is your population. So before you think of a sampling procedure, first you should know what to do with them. What do you want to do with the policy holders? What do you want to get from them? Okay. So it is essential that you should be very clear about what you want to know about that. For example, if you want to know whether the premium they are paying is on the higher side or not, if you want to know whether they would recommend LIC policies to their known people in and around, whether if there is any opportunity, whether they would canvass for that. Okay. Or another question, whether in the long run, the various schemes in LIC, whether they would be beneficial to the households or not. See, first you should ask the kind of questions. The researcher should formulate the questions. And depending on seeking answers to those questions, you will have to pick up the sampling procedure. But one thing is clear, your population is very clear. That is the policy holders from LIC. Okay. Suppose if you want to know their opinion about, say, various products of LIC, okay, so then you again have to divide the population into strata, that is high income groups, middle income groups, okay, because their preferences tend to be different. So in that case, you have to divide it into two strata, stratified, say, upper income strata, lower income strata. Then within that, you may go for the systematic sampling. That may be, or you may even go for the random sampling within that.
Sir, he has sent one additional question, same person, that
Yes.
he want to study customer satisfaction regarding service provided to customers by LIC. Customer
Okay.
satisfaction.
Okay, fine. Yeah, that's a good question. So how satisfied are the customers? So that is the question. So you are approaching the customers with a questionnaire, isn't it? Customer, whatever be the strata from which he hails, okay. In my view, in this context, the simple random procedure, use randomly select. Suppose in your database, you have, let us say, 1,000 customers. Okay. So from among the 1,000 customers, you randomly pick, let's say, 100 by covering 10%, right? So one procedure is that you randomly select either by lottery method or by generating random numbers method. Another alternative is, okay, you arrange them in some order, not necessarily according to income groups or whatever it is, or according to the size of the premium, etc. You arrange them in some order. First, let us say, pick the fourth one, then again go for the 14th one, like that. In a very systematic way, also you can pick up. Then from them, you ask for the feedback. You ask for the feedback. So this is one way. Another way is, again, as I said, uh, customers' preferences tend to vary according to their income strata. So divide them into two strata. Okay. For one strata, you slightly modify the questionnaire. Okay. The same questionnaire should not be implemented on both. Then you will get possibly the correct kind of feedback. Okay.
Okay, sir. So second question is from Subhashish Misra, and
Mm.
he's asking what is the difference between cluster sampling and multi-stage sampling?
Okay. See, in multi-stage sampling, the sample is drawn not in one go, but in different stages. Okay. So in clusters, first you identify the clusters. Okay. Clusters are naturally formed clusters. Okay. According to some established, they exist already beforehand. Like, for example, certain regions. That region is a cluster. Or certain groups, say, for example, religious groups. Okay, that is a group like that. In the first stage, you identify the clusters. So clusters, if they are dissimilar, you can't identify them randomly, right? So you will have to divide the clusters into various blocks. For example, if the idea is to collect information about respondents from districts, districts are dissimilar. Some districts are advanced, some districts are, uh, you know, middle income districts, say within a state. So therefore, you form clusters. That means you first, suppose if there are 4 districts which are well developed, you select one district randomly. So that is where simple random procedure works. And similarly, the poor districts, you select randomly one poor district. And within a district, suppose there are mandals. Suppose there are, say, 15 mandals in a district. So you randomly select. So like that, stage wise, first you select the districts. Then within that districts, say developed districts and not so well developed district, you apply simple random principle, identify the blocks, and from each block, then you either go for the simple random technique principle, or you may go for the systematic principle, like that every 12th farmer, then every, like that you identify, and that is where you can have a mix of simple random as well as systematic sample procedures. Okay. So this is how you call it as a multi-stage, not in one stage, but in a sequence of stages. Yeah.
Yes, sir. The previous same person,
Mm.
Dhaneswar, who was asking about LIC.
Yeah.
Now he has asked another question just to add to that. That
Mm.
if data is so much large, suppose 1 lakh customers taken policies from LIC, so how can select with the help of simple random sampling? If population is very large, how simple random will help?
See, simple random helps when the population is homogeneous. But in the case of LIC, you have so many policies. Each policy has a particular premium. So you will have to divide the entire customers according to the size of premium, for example, into 4 or 5 categories. So each of the categories is a strata. So from each strata, you pick up, uh, again, assuming that each strata is having a homogeneous category of customers. Some assumption is required because, there's no way that, to ensure uh, uniformity. What prevails normally is a lot of heterogeneity. But you have to make some assumptions, divide them into possibly certain finite number of strata. From each strata, you can apply a simple random principle. So it is a combination of both. In the first stage, stratified sampling. In the second stage, simple random sampling.
Sir, next question is from Adi Vepa, and he is asking what should be optimal number of samples in survey for successful completion of research? Sample size he is asking, sir.
Yeah. Actually, sample size computation is based on two, three important parameters, as I just said. One is size of the population. Then second is the sampling error. Okay. The third is the confidence level. That is the level of confidence. So all these parameters have to be fed into then the desired sample size, right? So, and also the standard deviation of the sample. So by feeding all these parameters into the formula 1, where you arrive at a sample size when the population is finite, and another a sample size where the population size is infinite. It's slightly modified formula is there. So you feed them and get your sample size, desired sample size. So the desired sample size uh, varies with the population size, because formula will be different. So optimal sample size within a category is possible going by the formula using Z scores and the parameters that are already set. I think computations are there, sample size computations. So one could make use of them and arrive at that. Any
Sir,
other?
next question is from Akansha Tigga.
Yeah.
And she's asking what would be a perfect sampling technique if the population is MMOG player? MMOG is massively multiplayer online game.
Hmm.
Online game players. So which technique is good?
Actually, that game is not familiar to me.
Yeah, I also don't understand, but by
Yeah.
name it looks like it may be a game which I can play online and anyone can join that game online, internet.
Okay.
So
Okay.
we are not face to
What is
face.
the objective of this game?
It may be any game. I don't know, sir. I don't have idea about this, but I'm just assuming. Just suppose it is a chess or something like that.
Yeah.
So anyone can join it online. I don't know who is that, and I'm playing
Okay.
something like that.
Yeah.
But massively means it must be multiplayer, where a big number of players.
Yeah. Millions of people may be participate.
Yes, something like that. Yes.
Okay. So what is the question in this context?
So which sampling technique is good for this? Perfect for this?
See, we do not know the background of players.
Yes.
And we also do not know the objective. The objective is simply they are playing for pleasure, or they are playing for some money or for some other gain. That we have to see. Obviously, it looks like, since people are joining the game randomly, you can pick up people to ascertain their views on a simple random basis, randomly. I'm not very sure about this because the nature of the game I do not know, and the type of players that enter into the game, though randomly, those things need to be understood before suggesting any technique.
So the next question is from Priyanta Ghosh, and actually two, three questions are there.
Yeah.
Is there a popular formula for sample size selection?
Yes. Yes.
So then
Yeah.
what? Yes, sir. Any?
Yes. 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 Uh, well-established procedures are there. I think when you Google search, within no time, I think you'll be able to
Yeah.
get even right now.
Sample size calculators are also available
Yeah,
easily.
yeah, sample size calculators. Uh, once you feed the population size, then their Z squares, the margin of error, and standard deviation. You have one formula for arriving at the sample size, whose population is known. That is, sample size n is known, capital N is known. And another formula where n is unknown, you have another formula. I think they are all well
Yeah.
established, very mechanical and statistical formulae are there.
Mm.
But only thing is the level of confidence you have to feed that.
Yes.
Then margin of error you have to feed,
Mm.
and the estimate of standard error you have to feed, and sample size anyway. If you know it, you also feed that. Then the sample size is given quickly by the formula. Hmm. So it's a combination of somewhat discretion and some information which is known to you beforehand.
So a subsidiary question from her is what percent of population sample would be? So I think, sir, it is not in percentage way. Some
Mm.
other things are there. So
Mm.
calculator will help in that.
Yes, yes, yes. It helps. Only thing is you have to accept that.
Yeah, yeah. That depends if population is very small, large sample size required. If population is very large, then a small percentage will do. So it is not fixed like 10%. Now we cannot say exactly this percent.
Yeah, yeah. That 10% is arbitrary.
Yeah, yes, yes. So
In
it should
fact,
not be
that
in percentage term.
yeah, yeah. But
Depends on population.
yeah, number you will get.
Yes. Then a subsidiary
But
question from same is, sir, can you kindly repeat the difference between cluster sampling and stratified sampling?
yeah. See, in the case of strata, you are dividing the population into certain stratas based on some considerations. Whereas in the case of a cluster sampling, clusters are already formed. They're already there. For example, when you are viewing the Indian economy in terms of states, states are known, boundaries are very clear. Okay. So in the case of clusters, these clusters are known, they are pre-existing clusters. Okay. Whereas in the case of the strata, okay, you are dividing it into strata. Possibly a homogeneous collection, you are putting it as one strata. Another homogeneous collection, you are putting it another strata. So there is discretion in dividing the population into strata. Whereas in clusters, they're already given to you. That is the difference. So once clusters are formed, or once clusters are decided, or the strata are decided, then you go for either simple random sampling techniques or systematic sampling, but within the strata.
So next question is from Priyanta Ghosh, again same. Question is NSSO
Mm.
follows multi-stage sampling.
Yes,
Okay.
yes, yes, it does.
And one more question is there. I think this is last so far. This is from Daneswar, same person who asked about LIC. And
Mm.
now question is, can we use more than one sampling technique in the selection of sample?
Yes, it depends on the nature of the population. In the case of LIC, the reference point is LIC, I guess.
Yes, yes, yes.
Yeah, yeah. In the case of LIC, you need to use not one, but different sampling techniques. The first, if the purpose is to know how satisfied are the LIC customers, you need to stratify them into various groups, in at least some 2-3 groups. So from each group, you have to elicit information. And for that purpose, you need to select a sample. That could be according to simple random technique, or that could be according to the systematic sampling. But so therefore, in his context, I would suggest two sampling techniques. One, stratified sampling, then after that, simple random sampling or systematic sampling.
Sir, another question came from Dr. Ashok Sharma. He's asking, is it possible to conduct probability sampling if the population size is unknown? What is the optimal sample size in such cases?
See, in fact, when the population size is unknown, depending on what you want, depending on your target, okay? So probability sampling techniques are preferable in the sense that in most cases, what we think we know about the population, we are really ignorant about it, okay? But we make some broad assumption that the population is infinite. It's very large. The right word could be large. In the case of large populations, probability sampling would be preferable. Again, depending on the objective, we need to pick up one or the other of the techniques that I just listed. That is simple random, systematic, cluster, or stratified.
Sir, I would like to add one more thing in the same question. Just suppose I don't have idea about population, like number of OPD patients. I don't know how many will come. So in that case, how to select random sample?
See, normally OPD cases are cases which are non-hospitable.
Yes.
They don't get admitted into the hospital. Okay. So they may mainly come for consultancy or for some small ailments. So, but you can't find out from each of these because you do not know how many will arrive on a particular day. That number is not known. Okay. Suppose now you go there in the OPD section and pick up people randomly, say when they're waiting or so. Okay. So the picking up process can be based on simple random principle. Either you use some codes and according to the codes you can call them, okay, or you can approach them and elicit information, right? So what I mean to say in one sentence is that for OPD patients whose population is not known, because so many people may be wanting to visit hospital, but you may not know that particular number. On a given day, a few people turned up. Now you want to know some information about the people who are already turned up. There, the best technique is simple random technique. You randomly pick up somebody and elicit information that you want. So I would suggest simple random technique principle for that.
Sir, I would like to add another question in the same. Just suppose I want to survey all adults in a city for some purpose. So there may be 3 lakh, 2 lakh, 50,000, something like that. Earlier this question came.
Yeah.
So now how to select randomly because I don't have proper sampling frame.
Okay. So again, who is an adult you have to define.
Okay.
Is it that all those above the age of 21? Yeah, it could be. So you may define an adult as someone who is above certain age, say either 18 or 21. Okay. So taking one of them has granted, they are all adults, okay? In a particular city, how many adults are there? I think this information is not very difficult to get.
Yeah, it is possible, sir. Yes.
It is possible.
Yeah.
See, once you have that information, then the sampling procedure depends on what do you want to know from them. Okay. So if you want to know whether the medical care that is being extended by the government is sufficient or not, for example, I'm just citing this as an example.
Okay.
Then you pick up people maybe above the age of 45. Those adults who are prone for Medicare and who are, let us say, not from so well-off communities, right?
Yeah.
You form a strata and you pick up a sample from that. Okay? Suppose you want to know whether the education system or the education facilities that are being offered to the citizens, whether it is satisfactory or not, then you pick up people who are in the age group of, say, 18 to 25. Find out their feedback, whether they're satisfied or not, like that. Depending on the purpose, the whole adult population could be stratified into certain groups. And from each group, you elicit information that you may like to have.
Okay, sir. So no more question now, sir.
Okay.
So we can finish the session here.
Yeah. So thank you very much, Professor Singh, for inviting me for this refresher course. And I also thank the university for extending invitation to me. Thank you.
Thank you, sir, on behalf of MMTTC, MZU, and all the participants for your presentation and taking care of all the queries what came. Thank you, sir. And in future also, we'll be calling you for some others. Thank you, sir.
Most welcome, sir. Most welcome. Right.